Hello, hello, hello. ಯಾಕಪ್ಪ ಯಾರು ಕ್ಲಾಸ್ ಜಾಯಿನ್ ಆಗಿಲ್ಲ? Please inform others to join if you are traveling. Uh-huh. I'm waiting since 10 minutes. Hmm. Nidhi, why you did not join the class?
ಸರ್ ಟುಡೇ ಇತ್ತ ಸರ್ ಸರ್ ಆ್ಯಕ್ಚುಲಿ ಅಮ್ಮಂದು ಹಾಸ್ಪಿಟಲ್ ಹೋಗಿದ್ದೆ ನಾನು ಅದು ಫಿಸಿಯೋಥೆರಪಿ ಟ್ರೀಟ್ಮೆಂಟ್ ನಡೀತಿದೆ ನೀಡಲ್ ಥೆರಪಿ
Uh-huh.
ಅದಕ್ಕೆ 8 o'clockಗೆ ಹೋಗಿದ್ದೆ
ಈಗ ಅಲ್ಲಿ ಜಾಯಿನ್ ಆಗಕ್ಕಾಗಲ್ವಾ ಫೋನ್ ಮೂಲಕ?
ಅಂದರೆ ಸರ್ ಅಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಗಲ್ಲ ಅಂತ ಹೇಳಿ ನಂಗೆ ಆಮೇಲೆ ನನ್ನ ವಾಟ್ಸಪ್ಗೂ ಬಂದಿಲ್ಲ ಇವತ್ತು ಬೆಳಗ್ಗೆಯಿಂದ
ಬಂದಿದ್ಯಮ್ಮ, ಹಾಕಿದ್ದೀನಿ ನೋಡಿ.
ಅಂದರೆ ನಾನು ಆನ್ಲೈನ್ ಬಂದಿರಲಿಲ್ಲ ಸರ್ ಅದಕ್ಕೇನೆ
ಹ್ಮ್. ಬೆಳಗ್ಗೆನೆ
ಗೊತ್ತಾಯ್ತಾ ಐ ಆಮ್ ಸಾರಿ ಸರ್ ಇಲ್ಲ
ಪರೋ
ಅಟೆಂಡ್ ಆಗ್ತೀನಿ ಸರ್ ಇನ್ಮೇಲಿಂದ ಅಂತಂದರೆ ಡೆಫಿನೆಟ್ಲಿ ನೋಡ್ಬಿಟ್ಟು ಅಟೆಂಡ್ ಆಗಿರ್ತೀನಿ ಸರ್ ಲೈಕ್ ಇವತ್ತು ಬೆಳಗ್ಗೆ 8 o'clock
ಆಯ್ತಮ್ಮ, ಬೇರೆಯವ್ರಿಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡಿ. ಕ್ಲಾಸು ಆಗಲೇ
ಹಾಂ
10 ಮಿನಿಟ್ಸ್ ಆಗೋಯ್ತು, ಬೇರೆಯವ್ರಿಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡಿ.
ಹಾಂ ಸರ್
ಹಾಂ
ಓಕೆ ಸರ್
ಹಾಂ
ಹೇಳ್ತೀನಿ
ಓಕೆ. Good morning to all of you. I hope Good morning to all students. I hope eventually some more students will join the class. Yesterday we discussed Netcat commands. Also we discussed some other important topics like backtrack or also known as Kali Linux and some Unix basic commands. Today we'll discuss SSH, which is very important and basic one that you have studied maybe already. So we start with the SSH. SSH secure shell is access credential that is used in SSH protocol. In other words, it is a cryptographic network protocol. SSH is a cryptographic network protocol that is used for transferring encrypted data over the network. You are aware of encryption. Encryption is a process wherein data is plain text data is get converted into coded data, encrypted data through the process of encryption. We apply some protocol, some function to encrypt it. It is a cryptographic network protocol that is used for transferring encrypted data over network. It allows you to connect to a server or multiple servers without having you to remember or enter your password for each system, that is to log in remotely from one system into another, right? So it helps you in data transfer, that is encrypted data transfer over a network. You know public key, where public key can be everyone can see it, no need to protect it. It is used for encryption function, whereas private key stays in your computer or somewhere in a secret place. It should be protected, used for decryption function. Key pairs can be the following types: user key if public key and private key remain with the user, host key if public key and private key are on a remote system, session key used when large amount of data is to be transmitted. These are the types of key that SSH uses. Friends, you have to know what is SSH and what are the types of keys it uses and how SSH works basically. So in your examination, you may be asked to write a short note on SSH in depth. If they ask you to explain the working of SSH, obviously, since SSH works based on the encryption methods like RSA, DSA, and ED25519, you have to explain them in brief to explain how SSH works. We can say SSH uses asymmetric cipher for performing encryption and decryption. Friends, we have discussed a lot when we had a discussion of cryptographic functions. Asymmetric cipher means it uses different key for encryption and decryption. Public key for encryption in general, private key for decryption in general. So you should say how SSH work means it uses asymmetric cipher for performing encryption and decryption, and there are many encryption methods. Specifically, SSH goes for RSA, DSA, and ED25519. Even though in this PPT I have given more information, I will explain you what should be extracted from that, and you have to write in your the examination. However, the more information is given for just for the reference purpose. RSA is an algorithm which SSH uses, and RSA stands for Revis, Shamir, and Adelman, as an algorithm used by modern computers to encrypt and decrypt messages. It's an asymmetric cryptographic algorithm. Asymmetric means that there are two different keys. This is also called public key cryptography because one of the keys can be given to anyone. I repeat, RSA stands for Revist Shamir Adelman, which is an algorithm used by modern computers to encrypt and decrypt messages. It is an asymmetric cryptographic algorithm. Asymmetric means there are two different keys, public key and private key. RSA is also known as public key cryptography because one of the keys can be given to anyone, you need not protect it. DSA algorithm is the another algorithm on which SSH works. DSA algorithm works in the framework of public key crypto systems and is based on the algebraic properties of modular exponentiation together with discrete logarithm problem, which is considered to be computationally intractable. The algorithm uses a key pair consisting of a public key and a private key. The private key is used to generate digital signature for a message, and such a signature can be verified by using the signer's corresponding public key. The digital signature provides message authentication. The receiver can verify the origin of the message. Integrity, the receiver can verify the message has not been modified since it was signed. And non-repudiation, sender cannot falsely claim that they have not signed the message. This is DSA algorithm, which is another algorithm used by SSH. ED25519 is a public key signature system with several attractive features. This is the third main algorithm SSH uses today. Some more algorithm or some other modified algorithm SSH may use, but basically you can concentrate on RSA, DSA, and ED25519. Their brief explanation is sufficient because we are supposed to explain SSH, not ED25519, since SSH uses ED25519. To some extent, we should know about this algorithm also. ED25519 is a public key signature system with several attractive features. It's a fast single signature verification algorithm. The software takes only few, okay, compared to others, which takes of the order of 2,73,364 cycles to verify a signature on Intel's widely deployed system. It is a faster batch verification system. The software performs a batch of 64 separate signature verifications, very fast signing. The software takes only 87,548 cycles to sign a message. So this is how it is measured. Fast key generation. Key generation is almost as fast as signing. High security level. This system has a 2 to the power of 128 security target. Breaking it has similar difficulty to breaking NIST P256. Foolproof session keys signatures are generated deterministically. Collision resilience, hash function collision do not break this system. No secret array indices. So these are some of the features. Some of these features you can write in the examination, and you need not go in depth of all these things. Coming back to the SSH, general procedure is public keys from the local computers are passed to the server which is to be accessed. This is the general procedure what we are discussing with respect to SSH. Public keys from the local computers are passed to the server which is to be accessed. Server then identifies if the public key is registered. Key should be registered. If so, the server then creates a new secret key and encrypts it with the public key which was sent to it via local computer. This encrypted code is sent to the local computer. This data is unlocked by the private key of the system and is sent to the server. Server, after receiving this data, verifies the local computer. SSH creates a route and all the encrypted data are transferred through it with no security issues. SSH keys based authentication is not prone to brute force attack. It is more convenient, secure than login IDs and passwords, which can be stolen in the middle. There is no exposure of valid credential if a server has been compromised. So this is what you have to learn with respect to SSH. Next, we'll go to data pipe. Before going to the data pipe, let me explain the basics of what is a pipeline, then data pipeline or data pipe. Okay, pipe system call. Pipe system call prerequisite. You should know the IO system calls. What are IO system calls? So please recall what is IO system call. Conceptually, a pipe is a connection between two processes such that the standard output from one process becomes the standard input of other process. In Unix operating system, pipes are useful for communication between related processes, right? Pipe is a connection between two processes such that standard output from one process becomes the standard input of the other process. That is the purpose of using the pipe. In Unix operating system, pipes are useful for communication between related process. We say inter-process communication. If pipe is one-way communication only, that is, we can use a pipe such that one process write to the pipe and the other process reads from the pipe. It opens a pipe which is an area of main memory that is treated as a virtual file. So pipe is basically a main memory area and it is a virtual file. The pipe can be used by creating process as well as all its child processes for reading and writing. If the pipe is created, its childs can also use that pipe for reading and writing. One process can write to this virtual pipe or pipe and another related process can read from it. If a process tries to read before something is written to the pipe, the process is suspended until something is written. The pipe system call finds the first two available positions in the process's open file table and allocates them for read and write ends of the pipe. So here is a thing, right? Process P0 and P1. So here a process writes into the pipe, and P1 writes, and P0 is a process which reads the information. Pipeline. Now we go to pipeline. Just we have seen what is a pipe. Pipe is an interprocess communication. It's a one-way communication. A process can write the information into the pipe, which is a virtual file in the main memory, and other processes can read it. Generally, one process writes, another process reads. If a pipe is created by a parent process, its childs can also make use of the same pipe for reading and writing purpose. That's what we have seen so far. Now we look at pipeline. In Unix, like computer operating system, a pipeline is a mechanism for interprocess communication. In Unix, like computer operating system, a pipeline is a mechanism for interprocess communication using the message passing. A pipeline is a set of processes joined together by the standard stream so that output text of each process, we call std out, is passed directly as input std in to the next one. The second process is started as the first process is still executing, and they are executed concurrently. The concept of pipeline was championed by Douglas McClory at Unix ancestral home of Bell Labs. During the development of Unix, shaping its toolbox philosophy, it is named by analogy to a physical pipeline. A key feature of these pipelines is their hiding of internals. Ritchie and Thompson, 1974. This in turn allows for more clarity and simplicity in the system. We talk about anonymous pipes here, where data written by one process is buffered by the operating system until it is read by the next process. And this unidirectional channel disappears when the process are completed. This differs from named pipe, where messages are passed to or from a pipe that is named by making it a file and remains after the process are completed. The standard shell syntax for anonymous pipes is to list multiple commands, okay, prepared by vertical bars. We call them as pipes in common Unix terminology. For example, we write like this: process 1 pipe, process 2 pipe, and process 3. There is a picture which explains how these things happens, right? From keyboard, it is a process. From keyboard, we take the input for program 1 for execution. So std in is given as the keyboard, std out is becomes std in for the program, and program 1 output becomes std out output. Std out of program 1 becomes std in to program 2. Program std out of program 2 becomes std in for program 3. Similarly, error also. Generally, we have three types: std in, std out, and stdr. And you know that std out and stdr are associated with the display. So program 3 may eventually send stdr to display or std out to display. In this picture, we can see program 2 sends stdr to display. Program 1 sends stdr to display. So this is an idea of how pipeline works, right? Pipeline in computing. In computing, a pipeline is also known as data pipeline. So please understand that in a computing context, the pipeline The pipeline is basically inter-process communication. One process can take the output of it as an input to the another process. So far we have seen pipeline. Now we are talking about data pipeline. Pipeline in computing in that context is known as data pipeline. In your syllabus you have data pipeline. So far we had an introduction to make you to understand the data pipeline. Data pipeline is a set of data processing elements connected in series. It's a serial connection where the output of one element is the output of the next one. The elements of pipeline are often executed in parallel or in time sliced fashion. Parallelly, they may get executed or in a time sliced fashion, in a round robin fashion. Some amount of buffer storage is often inserted between the elements. Computer related pipelines include instruction pipelines such as classic RISC pipeline, which are used in central processing unit CPUs and other microprocessors to allow overlapping execution of multiple instructions with the same circuitry. The circuitry is usually divided up into stages, and each stage processes a specific part of one instruction at a time, passing the partial result to the next stage. Example of stages are instruction decode, arithmetic, logic, and register fetch. They are related to the technologies of superscalar execution, operand forwarding, speculative execution, and out of order execution. Friends, you have to know what is data pipeline and just instruction pipeline, further graphics pipeline, software pipeline, HTTP pipelining. These basics definitions you should know. Instruction pipelines we have seen. Now we will just see what is graphics pipeline. Found in most graphic processing units, GPUs we say, which consists of multiple arithmetic units, or complete CPUs that implement various stages of common rendering operations: perspective, protection, projection, windows clipping, color, light calculation, rendering, etc. So graphic pipeline uses in graphics processing units. Please remember that. Software pipelines consist of a sequence of computing processes. Commands, program runs, tasks, threads, procedures, etc. We call them as computing processes. Conceptually executed in parallel without output stream of one process being automatically fed as the input stream of the next one. The Unix system called pipe is a classic example of this software pipes. So Unix system pipe implements software pipes. The next one is HTTP pipelining, the technique of issuing multiple HTTP requests through the same TCP connection without waiting for previous one to finish before issuing a new one. Some operating system may provide Unix-like syntax to string several programs run in a pipeline, but implement the latter as simple serial execution rather than true pipelining, right? So these are the some data pipeline with respect to that. So you write what is the pipeline, what is interprocess communication, then what is data pipeline. As we have discussed, pipelining is a commonly used concept in everyday life. For example, in the assembly line of a car factory, each specific task such as installing the engine, installing the hood, installing the wheels is often done by a separate workstation. The stations carry out their task in parallel, each on a different car. Once a car had one task performed, it moves to the next station. Variation in the time needed to complete the task can be accommodated by buffering, means holding one or more cars in a space between the stations, and or by stalling, means temporarily halting the upstream stations until the next station becomes available. Suppose that assembling one car requires three tasks that take 20, 10, and 15 minutes respectively. Then, if all three tasks were performed by a single station, the factory would output one car every 45 minutes. By using a pipeline of three stations, factory would output the first car in 45 minutes and then a new one every 20 minutes. As this example shows, pipelining does not decrease the latency, that is, total time for one item to go through the whole system. It does, however, increases the system's throughput, that is, rate at which new items are processed after the first one. So, in that way, we can think of with respect to the pipes. Design considerations, balancing the stages, since throughput of a pipeline cannot be better than of its slowest element. Designers should try to divide the work and resource among the stages so that they all take the same time to complete their task. In the car assembly, for example, given above, if the three tasks took 15 minutes each instead of 20, 10, and 15 minutes, the latency would still be 45 minutes. But a new car would then be finished every 15 minutes instead of 20. So, this is how you can balance the various stages. Okay, just we have to see what are non-linear pipelines. If some stages takes much longer than the other, cannot be speed up, designer can provide two or more processing elements to carry out the task in parallel with a single input buffer and a single output buffer. As each element finishes processing its current data item, it delivers it to the common output buffer. Costs and drawbacks. A pipelined system typically requires more resources, means circuit elements, processing units, computer memory, etc., than one that executes one batch at a time, because its stages cannot share those resources, and because buffering and additional synchronization logic may be needed between the elements. Moreover, the transfer of items between separate processing elements may increase the latency, especially for long pipelines. The additional complexity cost of pipelining may be considerable if there are dependencies between the processing of different items, especially if a guess and backtrack strategy is used to handle them. Indeed, the cost of implementing that strategy for complex instructions set has motivated some radical proposals to verify computer architecture, such as RISC and VLIW. These are certain informations that you have to see. Okay, and you can just understand these things. Friends, a lot many informations are given here uh, just to have the completeness of the idea. Okay, so we discussed in the module 4 Unix command line. Okay, the Unix shell is used to run commands, as you are aware, and it allows users to pass runtime arguments to these commands. These arguments, also known as command line parameters, that allows the users to either control the flow of command or to specify the input data for the command. So, in Unix commands, I have asked you to remember certain basic commands like ls for list your files. Okay, ls um, dash L lists your files in long format. ls dash EA lists all files including the ones whose file names begins in a dot like this. Please remember. And file compression, I have asked you to specifically focus on ggzip file name and gunzip file name, gzcat file name. Gzip file name compresses the file so that they take up much less space. Usually text files compress to about half their original size, but depends very much on the size of the file and nature of the contents. There are other tools for this purpose, as I have already told you. For example, compress, but ggzip usually gives the highest compression rate. ggzip produces files with the ending .gz appended to the original file name. Unzip file name uncompresses the files compressed by ggzip. Gcat file name lets you look at gzipped file without actually having to gunzip it. You can even print it directly using gcat file name pipe lpr. Printing I, L, IPR uh, file name, LPR file name. Print use the dash p option. So please go through such commands. Directories, these are again listed under basics of Unix commands. Make directory, dot mkdir directory name, cddir name, pwd tells you where you currently are, ff find files anywhere on the system, right? These commands you are expected to remember. About the people, w tells you who is logged in, what they are doing, especially useful, right? uh, who who command tells you who is logged on and where they are coming from. Useful if you are looking for someone who is actually physically in the same building as you or in some other particular location. Figure username gives you lots of information about the user. Example, when they last read their mail and when they are logged in. But often people put other practical information such as phone numbers, address, etc. Class. Who am I returns your username sounds useless, but it is not. You may need to find out who forgot to log out somewhere and make sure you have logged out. Okay, fine. And we also discussed a backtrack Linux. Backtrack was a Linux distribution that focused on security. Earlier, we had different versions of Backtrack. In March 2013, the offensive security team rebuilt Backtrack around the Debian distribution and released it under the name Kali Linux. Friends, please note down that you have to explain what is Kali Linux and different types of functionality or features that can be done using the Backtrack Linux or Kali Linux as recently are named in 2013 March. Tools which are comes along with the Backtrack are tools for information gathering, vulnerability assessment, exploitation tools, privilege escalation, maintaining access, reverse engineering, RFID tools, stress testing, forensics, reporting tools, and services, and miscellaneous. So you should be able to name them with respect to backtrack Linux. The next important topic is Mac ports. Mac ports were formerly called as Darwin ports is a package management system that simplifies the installation of software on the Mac OS and Darwin operating system. It's an open source software project to simplify installation of other open source software. Syswin is a large collection of GNU and open source tools which provide functionality similar to a Linux distribution on Windows. Syswin is not a way to run native Linux apps on Windows. You have to remember this. Syswin is not a way to magically make a native Windows as aware of Unix functionality like signals, etc. But Syswin DLL currently works with all recent commercially released 8664 versions of Windows. Syswin, the most recent version is DLL 3.1.4. You can set up, you can have an installation of Syswin in your system. You have to look for Syswin setup hyphen x86 underscore 64 dot exe. Netcat utility program supports a wide range of commands. Netcat is another important topic that we have already discussed. I am just revising that Netcat utility program supports a wide range of commands to manage networks and monitor the flow of traffic data between systems. Computer networks, including the World Wide Web, are built on the backbone of the transmission control protocol TCP and user datagram protocol, right? So it works both on TCP and UDP. You can do many things with respect to Netcat commands, create a chart or web server, verbo scan with Netcat commands. You can do HTTP requests with Netcat commands. You can do TCP server and TCP client commands. You can do item with Netcat commands. We can do prevent DNS lookup with Netcat commands. You can do. So, friends, please note down. You should remember some basic Netcat commands. Once you have a Netcat application set up on your Windows or Linux server, you can start running basic commands to test its functionality. Here are a few to get started with. Okay, nc help. This command will print a list of all of the available commands you can use in Netcat. Nc z v site.com. This will run a basic port scan of the specified website or server. nc-l, this command will instruct the local system to begin listening for TCP connection. The listening is accepting, understanding, processing, in case of active listening, even responding also. So those things have to be done with respect to TCP connection and UDP activity on a specific port number. So such some of the basic commands you have to remember. Since a detailed specific commands are not given in the syllabus, the basic general description of Netcat commands and Netcat software you can write, and its basic commands you have to remember some of the basic commands. can create a chart or web server. As I have already discussed, chart programs are on the rise from open source solution to those that seems to suddenly gain massive popularity. There are a wide range of chat and communication tools are available to enterprise organization. The reality is that some IT experts and system administrator would prefer a simple text only solution. In that case, you can have your own text chart uh, application. Windows Netcat can actually fill the need and allow for the transmission of messages across a local network. Okay, HTTP requests with Netcat commands can be done. Uh, uh, that just you can go through it. TCP and UDP related work you can do with the Netcat commands, TCP server and TCP client commands. Although the TCP protocol is primarily used for transferring web traffic around the world, it can actually be implemented at a local level for file transfer. To accomplish this, you can you need to run Netcat from two locations, one that will act as a server to send the file, one that will act as a client to receive it. So these are things possible. So after this, we discussed with respect to the SSH in today's class. SSH, as you know, is a access used secure shell access credential that is used in SSH protocol. It's a cryptographic network protocol used for transferring encrypted data over the network. It allows you to connect to a server or multiple server without having you to remember or enter your password for each system. That is to log in remotely from one system to into another. It always comes in key pair, right? So I have already told you SSH uses public key, private key, and key pairs can be user key, host key, and session key. And SSH works based on RSA, DSA, and ED 25519 algorithm. RSA, as you are aware, reversed Shamir and Adelman algorithm used by modern computers to encrypt and decrypt messages. It is an asymmetric cryptographic algorithm. Asymmetric means that there are two different keys. This is also called as public key cryptography because one of the keys can be given to anyone. The DSA algorithm works in the framework of public key crypto systems and is based on the algebraic properties of modular exponentiation together with the discrete logarithm problem, which is considered to be computationally intractable. The algorithm uses a key pair consisting of a public key and private key. A private key is used to generate digital signature for a message, and such a signature can be verified by using signal's corresponding public key. The digital signature provides message authentication. Receiver can verify the origin of the message. Integrity, the receiver can verify that the message has not been modified since it was signed. And non-repudiation, the sender cannot falsely claim that they have not signed in the message. So these things are discussed already. Pipe, data pipe, right? And in the next class we will discuss F pipe, and that the end of the after discussing the F pipe we can say we have completed the 100%. I think in the next class within a half an hour we can F pipe concept in Unix. That completes the fourth module. I thank one and all for patiently listening. Please inform your friends to attend more in number, because in a very class, in a very session, definitely you'll be having some good information from the teachers to take it. So I thank everybody, and I'm closing this class. Thank you.